Okay, so in this video we're going to focus on the assessments available to us. So, assessment of simple linear regression model. So we've created the model, we have our equation. Remember, this is the equation of the best fit line using the least squares technique that we've described in a couple videos prior to this. Now what we want to do is we want to see whether this line is doing a good job. We want to judge it. We want to assess it. Okay? So there's a couple tools available to us, and we're going to focus on them. The first is called the coefficient of determination. And the symbol for it is r squared, although Google Sheets will actually write out r squared, I believe. Okay, so they're the same thing. You can literally calculate r squared by taking the correlation coefficient that we described a couple videos back and squaring it. So they are related in that way. Okay? And if you square a number between -1 and 1, which if you remember the correlation coefficient was, you'll end up with a number between 0 and 1. R squared is between 0 and 1. Or if you like percentages, 0% and 100%. As you'll see, it's nice to convert r squared into a percentage and in order to interpret it. Okay, so let me give you an interpretation of it. What does r squared tell us? What does the coefficient of determination tell us? Okay, well, it gives us the proportion, so let's write this. Of variation in y, so whatever your y variable is, that can be explained, or let me do / attributed to the simple linear regression or least squares regression line. Okay, this guy that we just described. So basically, how well is this doing at explaining the y variable, the dependent variable? Well, r squared will range from 0 to 1. Obviously, having an r squared closer to 1 is telling you that this line is doing a better job at predicting the y variable. So obviously the y variable is going to depend on the problem you're working on. Sometimes you're trying to predict house price. Sometimes you're trying to predict income. Sometimes you're trying to predict sales. So your y variable is the one variable you want to predict. So that is what r squared is. We'll see this in an example when we go back in the next video. We'll go back and actually do this with the house price and square feet example that we started in Google Sheets. We'll end that example in the next video. We'll talk about r squared. The second assessment that's available to us that we're going to talk about here, so I'll just call this number 2, is what's called the model utility test. And this is basically a test of the slope. So this is a test of the slope of the regression line. So if we look at the regression line again, there's the y-intercept plus the slope times x. So we're testing whether this is significantly different than 0 or not. If you recall the scatter plots we looked at a few videos back, we had a scatter plot that looks something like this, where if you forced me to tell you what kind of relationship these two variables had, I would tell you there's no real relationship here, that it's basically a flat line. Look at what this, by the way, this is x and this is y, right? Look at what happens to the flow of these points as you go up in the x direction. What happens to y? Nothing really, right? There's no clear pattern upward or downward here. It's flat. That tells me that there's no real relationship between these two, right? So I express that with a straight line. The slope of this line is going to be 0. So if you say a slope is 0, you're saying that there's no meaningful or significant relationship between x and y. Okay? So let's get back to our equation here. Recall that this equation that we came up with, we've already started this process. We already got this guy and this guy from Excel Miner, and we were able to write out this whole equation. Remember that these two guys are estimates of their population versions. For example, B0 is an estimate of beta 0. This is the true slope. If we had all the population data, which we don't, we have sample data, we would be able to calculate B0 in the same way that beta 0 in the same way that we calculated B0. But since we have sample data, right, the best we can do is to estimate B0. And the same goes for the slope. We wish we knew what the true slope was, beta 1, but we settle for the sample data estimate of it with B1. So both these guys that we estimated are regression coefficients estimates. Keyword here. Okay? So keeping that in mind, we get to the model utility test, which starts out by assuming the null hypothesis is that the slope is equal to 0. Let's put this into words. What is this saying? This is saying there's no significant linear relationship between y and x. Okay? So we start out by assuming that there's no significant linear relationship between the two variables. The alternative hypothesis, however, is that beta 1 is not equal to 0, which in words is saying that the slope isn't equal to 0. We don't know if it's positive or negative, but there is some sign and some magnitude to that relationship. So in words, this is saying there is some, we don't know if it's positive or negative, but there's some significant linear relationship between x, or let's say y and x. Okay? So if you really want your model to have been doing a good job, then you would clearly wish you would reject here, right? But of course that's out of your hands, right? But just so we understand kind of what's going on here. Of course, all hypothesis tests have a null, alternative, and a level of significance. So let's just leave that blank for now. That's given to us in the problem. Now, in order to answer this hypothesis test with a decision, we would compare a p-value, which Google Sheets Excel Miner will give us, to alpha. So And remember the p-value method for making a decision in a hypothesis test. If the p-value is less than alpha, you reject HO. If the p-value is greater than alpha, you fail to reject HO. So clearly, if your model is doing a good job, you would reject HO here and have evidence that there is some significant linear relationship. Again, that's out of your hands. We're just trying to build up the intuition of what's going on here. So in the next video, I show you how to or where the R² value is in the output. Okay, Excel Miner will call it R². How to interpret it in the context of our real estate broker data set, and then how to set up the hypothesis statement and answer with a decision using the p-value, where to find that p-value in the Excel Miner output. Okay, so we have two methods now for judging or assessing our simple linear regression or least squares line, this guy. Okay, and then once we've done that and we're confident, we could then use that line to make predictions. So this is getting a little ahead. So then once I'm satisfied and I've judged this line, I've assessed it, and I see that it's doing a good job, basically model utility test and R², then I could start plugging numbers into here, and out will come predicted Y's. Okay, so we'll get to that at the very end of the next video. After we've assessed our model, we'll come to a conclusion on the model utility test and finally make some predictions, which seems to be the ultimate goal of this whole process. Okay, so hopefully this one was helpful. The next one we'll go back to Google Sheets and apply this theory that we just learned to that example that we've been working on. Okay, so till next time, have a great day.